And welcome to section 11.5. There are no notes for today. It's all examples because we are talking about how to take care of it when it's not pretty like it was before. Remember yesterday when we were doing elimination, we said you have to have a positive and a negative. It's the same number so that when you cancel them out, they're gone. Well, now there's not anything pretty to cancel out with. I mean, we could try to cancel out the 17s by doing an opposite, but that's not going to get rid of one of our variables, which is what we're trying to eliminate. So now we need to pick a variable to eliminate. I'm choosing to eliminate the L. So I've decided this is the one I want to get rid of. So now I need to find a way to make sure that these are the same numbers. Now we said yesterday that you could eliminate by multiplying one of them by something. So I'm going to choose to multiply the top one by 3. Yesterday we always multiplied by a negative, but nobody said we couldn't use a number. So I'm choosing to multiply by the number 3. So that means this will become, that's what that little arrow means, becomes 5 times 3 is 15k plus 9l equals 51. This one I'm not going to mess with. So I'm just going to move it over. And that'll be 2k minus 9l equals 17. Now I have something that'll cancel out, and I can go ahead and add them. When I do that, I end up with 17k equals 68. I can divide both sides by 17, and you get k is equal to 4. Now that I know what k is, I can plug that back into this equation, or this equation. But I have some room down here, so I'm going to go ahead and do it into this one. Plus, it's going to give me slightly smaller numbers. So that's going to be 2 times 4 minus 9l equals 17. So 8 minus 9l equals 17. Subtract 8 from both sides. Get negative 9l equals 9. Divide both sides by the negative 9. And l is equal to negative 1. Oh, don't box. I always want a box. Don't box. We're still doing elimination. K came first, so it's going to be 4, negative 1. If I wanted to plug it in, remember you have to plug it into both. So since we got it using this one, I'm going to plug it into that one. 5 times 4 is 20, plus negative 3 does give me 17, so it works. Let's give you one to try. Example 2. Give you a few seconds to think about it while I'm erasing. So, you can either choose to have gotten rid of the 10c by multiplying that one by negative 2, Or you could choose to multiply this one by a -3. Doesn't matter which one you multiply by or which one you do, because you're going to end up with the same answer for either. I'm going to choose to do times the 2 times the -2 on top. So that'll give me a positive 10c minus 6d equals a positive 32. And then I have my negative 10c plus d equals negative 22. That'll make those cancel out. Give me negative 5d is equal to a positive 10. So d is equal to negative 2. And then I can plug it back in to either here, here, or here. Let's go here. So I get negative 10c plus negative 2 is equal to 22. Sorry, negative 22. Add 2 to both sides. Negative 10c is equal to negative 20. C is equal to 2. Which makes your point to negative 2. Time for example 3. Another 17 one. Give you a chance to work on it while I erase. First things first, they're not even lined up. So I need to line them up first. So I'm going to rewrite them. This one looks like it's fine. So 9p plus 4q equals negative 17. But this one needs a rewrite. So that's going to end up being moving my 3p over here. I'd add 3p to both sides. That gives me 3p plus 12q equals negative 3. Now what do you want to get rid of? Well, how about we multiply by negative 3 on top? Or let's do the bottom one. Let's multiply the bottom one by negative 3. That way we get smaller numbers. I was looking up here, and if I multiply that one by a negative 3, that's going to be a big number. And while I know what it is, I don't know that you do. So we're just going to stick with the ones where we know. Well, we know. So on the bottom, that's going to give me negative 9p minus 36q equals a positive 9. And on top, I have a positive 9p plus 4q equals negative 17, where it just came over. That'll cancel out and leave me with negative 32q equals 8, negative 8. You're not going to like it. Q equals a positive 1/4. Don't fret. Just because we get a fraction there doesn't mean that it's going to be horrible up here. Make sure you pick one that'll make it not so horrible. So either one that I pick will be okay. In fact, I could go all the way over here if I wanted to. and pull any of these. But instead, I'm going to choose this one on top. Because that's going to give me 9p plus 4 times 1 over 4, which will make that cancel out, equals a negative 17. So now I get 9p plus 1 equals negative 17. 9p equals negative 18. P equals negative 2, which makes my answer negative 2 1/4. Nobody had to cry. But if you were doing it by graphing, it would be really hard to see that negative, that 1/4, because fractions are hard to figure out in graphing. It's okay. Alright, so we did 3, I got 2 more to do. Where'd my eraser go? Example 4, P equals 2Q, and 2P plus 6Q is equal to 5. We're supposed to have P's on top of P's, which we have, Q's on top of Q's, which we have, numbers on top of numbers. I suppose there could be a plus 0 there, which we have. But we also have to have equal signs on top of equal signs. And we don't have that right now. So in order to do that, I'm going to have to move my 2Q to the other side, which is going to make that P minus 2Q equals 0. And this will be 2P plus 6Q equals 5. And I rewrote that. Now, what would you like to multiply by? We can multiply this by a negative 2, get rid of the p's. We can multiply this one by a 3, get rid of the q's. I'm okay with that. Let's multiply this one by a 3. That way we don't have to worry about negatives changing and such. So 3p minus 6q is equal to 0, because that's what that becomes. And this one just comes over. 2p plus 6q is equal to 5. So that's 5p is equal to 5. P equals 1. Plugging it back in, doesn't matter where. 2 times 1 plus 6q equals 5. 2 plus 6q equals 5. Minus 2 minus 2. 6q is equal to 3. Q equals 1/2. I got a fraction. I don't particularly like fractions, so I want to make sure that it's right. I'm at least going to plug it into one of them. My original one was P equals 2Q. P is 1. Does 1 equal 2 times 1/2? And yes, it does. So I have more confidence now that it's 1 and 1/2. One more. I want you to work on this one. Pause the tape and work on it, and let's see if you can do it correctly before I do it. at it a minute and pause the tape and see how you do. I'm going to get rid of my ends. When I get rid of my ends, I'm going to have to multiply both of them by something. I'm going to choose to multiply the top one by 5. That'll make that a negative 10, which means I need to multiply the bottom one by negative 2. If you didn't know what you were going to do, but now you have some idea of how to do it, go ahead and try it from here. Pause the tape and try it from here and see how you do. On top, you get 25m minus 10n equals 40. On bottom, you get negative 6m plus 10n equals negative 2. Over here, that gives me 38. Over here, I have 19m. Divide both sides by 19. M equals 2. Now I can take it and plug it back into either of these. I'm going to choose this bottom one because it's on the bottom just like before. So 3 times 2 minus 5n equals 1. 6 minus 5n equals 1 minus 6. Negative 5n equals negative 5. Divide both sides by negative 5. N is equal to 1. Just to be sure that what we got was correct, plug it in. 5 times 2 is 10, minus 2 times 1 is 2. 10 minus 2 really is 8. 3 times 2 is 6, minus 5 really is 1. So yes, that is correct. That is about as hard as this gets, because we've gone over every single kind you can have for equations. Classwork and homework. Numbers 1, 5, 9, 13, and 17. And then homework is numbers 3, 7, 11, 15, and 19. One more section to do after this, and it'll be your last section in Algebra 1. Oh my goodness, oh my goodness. Okay, I'll talk to you later. Bye.